And back to the, all right, here we go. So I'm gonna run through this practice test. Now, if y'all have a question, stop me and ask, because otherwise I'll just kind of roll through to make sure we get done with this. So our practice test, and the test is very similar. There's not any surprises on the test. Oh, and I thought about something tonight. I decided that I would let y'all use a half page of notes front and back. Are y'all good with that? Or do you not want any notes? Okay, so you can use a half page of notes front and back. And when I say a half page, in other words, just take a standard size sheet of paper, you know, printer paper, notebook paper, whatever, fold it in half and cut it or tear it or whatever. You can write whatever you want on the front and the back. I just do that because if I said you can fill the front side of one sheet of paper, I'd have to go around and look at everybody's paper. Just a half sheet of paper, you can write whatever notes you want front and back. With that said, be careful, because students will try to write the entire chapter 2 on a half piece of paper front and back rather than learning the material. And if you have to consult your paper every time and read everything on it and try to figure out what you're doing on every problem, you're not going to do well. So prepare for the test as if you don't have notes, but I'm going to let you have a half page of notes front and back. Okay, with that said, let's get rolling here. And if you got questions, stop me. Otherwise, I'm going to roll along. So the first problem, it just asks which of these sets of ordered pairs are functions. We know that they're all relations because any set of one ordered pair or more is a relation, but which of these are functions? Does everybody agree that the set A is a function? Because all of my x coordinates are different, 2, 3, 4, and 5. Some of the y coordinates are the same, but that doesn't matter. The x coordinates, the first coordinates are all different. It is a function. B, that is also a function. I know you're expecting the x and y coordinates to be numbers, but remember, variables represent numbers. And all of these variables that are the first coordinates of all these ordered pairs are all different, which means that the numbers they represent are all different. That thing is a function. Part C, remember we talked about this. Any set that only has one ordered pair is automatically a function, right? You can't have two ordered pairs with the same first coordinate. If you only have one ordered pair, it's a function. Does everybody see, though, that the set D is not a function, right? Because I've got two ordered pairs here with the same first coordinate. Everybody good with that? Simple. Number 2 asks you for the domain of this function. It is a function. It asks you for the domain and the range. Remember, the domain is simply the set of all the x coordinates. It's the set of numbers 1, 3, and 5. It's the set of all the first coordinates of ordered pairs. The range is the set of all the second coordinates. So the range is just the set of numbers 2, 4, and 6, right? 2, 4, and 6. Everybody good there? So pretty easy. Problem 3. We are given a function, f of x equals 2x squared plus 3. We're simply asked to find some functional values. F of negative 2 just means plug negative 2 in for x and evaluate the thing. So it's going to be 2 times negative 2 squared plus 3. And so you need to do your order of operations. Do the exponentiation first. Negative 2 squared is positive 4. So that's 2 times 4 plus 3. And of course, 2 times 4 is 8, and 8 plus 3 is 11. So f of negative 2 is 11. That just means that in this function, when x is negative 2, the y coordinate that goes with it is 11. F of 0 is going to be 3. But if you don't just see that, like don't just fly through this and not pay attention to what you're doing. If you don't just see that, just plug 0 in place of x. But you should pretty quickly see that 0 squared is 0, and 2 times 0 is 0, and 0 plus 3 is 3. F of 3, well, that's 2 times 3 squared plus 3. We're just replacing x in this function with 3. Make sure you do the exponentiation first. In other words, don't make the mistake of going, oh, 2 times 3 is 6, and then do 6 squared, because order of operations says you do exponentiation before multiplication. So 3 squared is 9. So you have 2 times 9 plus 3. And 2 times 9 is 18, and 18 plus 3 is 21. So that's f of 3. Everybody good there? You're just plugging values into the function and evaluating it. Problem 4 asks you for each of these functions to tell if it's an even function, an odd function, or neither. And so remember, we've got that test where we test to see is f of negative x equal to f of x. If so, it's an even function. Or is f of negative x equal to the negative of f of x? If so, if it's an odd function. We don't need that. Because remember what we learned when we used that test is, if you have a polynomial function like all of these, if every term is of even degree, notice in f of x, our variable terms are 6th degree, 4th degree, 2nd degree. 6th power, 4th power, 2nd power. Remember, the constant term always counts as 0 power, so that's considered even degree. So every term is of even degree. 6, 4, 2, and 0 are all even numbers. Then this is an even function. Everybody see that? That is way too easy to miss. Does everybody agree in part B that g of x is neither? Do y'all see why it has to be neither, even, or odd? Because I got 5th degree, 3rd degree, and of course x is x to the 1st degree. Those are all odd degree terms, but notice also in this mix I have an even degree term, an x to the 2nd power term. If you've got a mixture of even and odd degree terms, it's neither even or odd. And then h of x, does everybody see that's going to be an odd function? I've only got terms of odd degree, 7th degree, 3rd degree, and of course x is the same as x to the 1st. Every term is of odd degree, 7, 3, and 1 are odd numbers, then it is an odd function. Everybody good with that? So that's an easy problem. Don't miss it. It's too easy to miss. Problem 5. I know I've drawn these graphs crappily, but you've got them on your practice test. Notice you're asked to give the graph symmetry for each of these functions. There's 2 types of symmetry we're interested in: y-axis symmetry and origin symmetry. This first graph has y-axis symmetry. Notice the graph is a mirror image of itself on either side of the y-axis. That is the definition of y-axis symmetry. Let's skip this middle one. Let's go to the last one. This third one is origin symmetry. Remember, here's the best way if you're nervous about messing up the one that says origin symmetry. Probably the best way to do it is look at your graph, and even if you have to do it at your desk during the test, if you have to do this, do it. Look at the graph, notice exactly what it looks like, and spin the paper around until the graph is upside down, until your paper's upside down. And if the picture of the graph is the same upside down as it is right side up, then that's origin symmetry. So I know that one's not perfect origin symmetry because, again, I just did a crappy job drawing it. But if we zoom in on this picture here, hopefully enough that we can all see it. Let's see if I can do this and make it where we can see it. Tricky now. I got to try to hang with me a second. So look, it's not just that you got a hump on the left, a dip on the right, but notice where that hump is on the left and the right. And if I turn it upside down, I've got a hump on the left and a dip on the right, and it looks just like it did before. Do y'all see that? That is origin symmetry. So let me zoom back out. Try to refocus. So we've got origin, symmetry. Now this one has neither. Do y'all see that? I mean, it should be obvious that that is not a mirror image of itself on the left and right side of the y-axis. Also, though, if you turn it upside down, notice you got a hump on the left and a dip on the right, but notice that hump on the left is right at the point 0, 0. If you turn it upside down, yes, you have a hump on the left and a dip on the right, but that hump is not at 0, 0 anymore. Y'all see that? That's not the same picture we started with. So that graph, let's just say it has no symmetry. So that's the graph symmetry they're asking about. Now, that's not the only thing they ask for in that problem. Do y'all see that? It says, and determine if each is the graph of an even function, odd function, or neither. So I sometimes have students who label the graphs with their symmetry perfectly, and then they move on to the next problem and they miss half the problem because they didn't read it all. It says, and determine if it's the graph of an even function, an odd function, or neither. So the thing to remember, every function whose graph has y-axis symmetry is an even function. Every function whose graph has no symmetry is neither even or odd. Every function whose graph has origin symmetry is an odd function. So make sure you answer both parts of that problem. Y'all see what I'm saying? Give the graph symmetry, then based on that, determine if that function is an even function, an odd function, or neither. Everybody good there? Problems 6 through 8 all use the same graph, and that graph on the practice test is not a great one to put on a test, not because the graph is hard to read, not because it's hard to answer the questions, it's just kind of hard to read the graph. But this is what you're supposed to be seeing roughly on the graph. The one that's on the test is a little bit bigger and it's drawn where I think it's a little more, like the font on these points I labeled is so small you can hardly read it on the practice test, but I think it's more legible and easy to see on the test. So problem 6 is asking us to give all the intervals on which this function is increasing and decreasing. And so, and I've just drawn kind of the main features of this graph. Somewhere out here should be, that should be 5. So remember, increasing, when you see where you see this graph rising from left to right, the function is increasing there. Notice the arrow out here means it's doing this forever, so it's always increasing all the way up until it gets to this point. Do y'all see that? Now, where students miss this problem is they don't answer the problem correctly. You're asked for intervals on which it's increasing and decreasing. That means the interval of x values over which the y value is getting bigger. The function is increasing. So remember, out here is the direction of negative infinity. And from negative infinity all the way up until I get here where x is -3, over that entire interval of x values, we see this function rising. So increasing, right? So it's increasing on the interval of x values from negative infinity to -3. Everybody with me there? Then it starts decreasing. And it's decreasing from here where x is -3 all the way until I get here where x is 2, we see the function decreasing. So it's decreasing, y'all look, on this interval of x values from -3 up to +2. Then it starts increasing again. When you get out here where x is 2, it starts increasing again. And it's going to keep increasing from the time x is 2 all the way up until x is 5. So increasing on the interval of x values from 2 to 5. And of course, it's not increasing after that because the graph ends. Everybody see that? So there's 2 intervals where it's increasing, 1 interval where it's decreasing. Now, if this had been an arrow on this end, do you agree that it would be increasing from 2 all the way on to infinity, right? But in this case, there's not. Everybody good there? Problem 7 asks us for relative maxima and minima. And I looked at one of the homework problems over the break from section 2.2 with a student. And so let me remind you, I had mentioned this back when we covered it. In the homework, when they ask you for a relative maximum, they ask you where does it occur. They want the x coordinate, right? Like what's the x value at which you have a relative maximum? That would be -3. Then they would say, what is the relative maximum? That would be the y coordinate too. But when I ask for relative maxima and minima, I'm just asking you to give me the ordered pair that represents the relative maximum point. Does everybody agree that would be here, that point, -3, 2? By the way, if your graph had arrows on both ends here, then for sure that would be the only relative maximum. Be careful here though. This graph has an end point, and a lot of students are tempted to say, oh, and 5, 4 is a relative maximum. It's not. Remember, an end point cannot be a relative maximum because you can't say that it's higher than points to its left and right because there are no points to its right. Everybody with me? So -3, 2 is the only relative maximum. And then there's one relative minimum point. It's this one. And that's the point whose ordered pair is 2, -5. And so our relative maximum point is -3, 2. Our relative minimum point is 2, -5. Everybody good there? Very straightforward. Just being asked to give the ordered pair that represents the relative maximum point and the ordered pair that represents the relative minimum point. Problem 8 asks you for the domain and the range. And I can't really get all, let me zoom out. I can't get that all on the page at once. So the domain, that's the set of all the x values. Y'all look. This arrow means this thing keeps going forever, and this x-axis keeps going forever to the left on toward -infinity. So look, the domain is not just, y'all look where I'm pointing here because this is important. Somebody's going to miss this, and then you'll have nobody to blame but yourself. So don't miss this. I will have students say, oh, the domain is a set of numbers -3, 2, and 5. They're looking at the x coordinates of the points that I marked. The problem is that's a tiny piece of the domain. What about all these other points on the graph that I didn't label? Those are still points on the graph, and the x coordinate of all those points is going to be in the domain, all those x coordinates. And those go from -infinity all the way up until we get to where x is 5. Anywhere you go along here, like even if you go way out here on the x-axis, if I look down far enough, because that graph keeps going, somewhere there's going to be a point on the graph that has whatever this x value is here as its x coordinate. So the domain goes from -infinity up to and including 5. So we need a square bracket there, right? Because if you, in this case, if you used a rounded parent around the 5, you'd be saying 5's not in the domain, but it is. That point is on the graph. Similarly for the range, except the range is asking you about the y values. Well, again, this graph goes down forever, so no matter how far down the y-axis I go, if I look across far enough, I'm going to see a point on the graph that has that y value as its x coordinate. So the range goes from -infinity up to, well, that's where y is 4, right? Up to 4. And again, we would need a square bracket there because 4 itself is in the range, right? That's a point on the graph. If this had been an arrow, if you had arrows on both ends, then both the domain and range would be all real numbers, right? from negative infinity to positive infinity. Everybody good there? Problem 9, we're just given a couple of equations and we're asked to graph those equations. The first one is just a very basic linear equation in slope-intercept form. So the simplest, easiest way to graph this, easiest way to graph this is to use the fact that this is in slope-intercept form. And B, the constant term, is the y-intercept. Well, that means the y-intercept is -2, so the graph hits the y-axis at -2. That's a point on the graph. M is the slope. Well, our slope is 3. And if you just write that as a fraction, the easiest way to write 3 as a fraction is to say it's 3/1. Remember, the bottom number is delta x, the top number is delta y. And so what that's telling me is, if I'm at any point on the graph, and this y-intercept is a point on the graph, +1 on bottom says that I go 1 unit to the right of that point. So I go right 1 unit. And +3 on top says now I need to go up 3 units. So from my y-intercept here at -2, I'm going to go 1 to the right and up 1, 2, 3. And that is another point on the graph, right? And so you need at least 2 points. Well, here are 2 points. You could literally draw the line that goes through it right now, and that's the graph. If you wanted more points, it wouldn't take but a second to do that, because from that point, you could go 1 to the right and up 1, 2, 3. And that would be another point. Or, y'all look, because I'm about to change this. +3, our slope is +3 over +1. It's also -3 over -1. So if you wanted to, you could also go back to your y-intercept, and now this says go 1 unit to the left and down 3 units, right? So go 1 to the left and down 1, 2, 3, and that would be another point on the graph. So get, at least a couple of those, and then draw the line that goes through it, and that would be your graph, right? You don't have to bring a straight edge. It doesn't have to be absolutely perfect. I should be able to tell if you've got the right graph or not, if you just hand draw it. Everybody good there? The B part of that asks us to graph x = 3. What is that graph going to look like? Somebody just tell me. A line? What kind of line? A vertical line? It is the vertical line that goes through 3 on the x-axis. Because notice on this vertical line, remember when we see x = 3, in other words, there's not even a y variable in the equation. Think of it like it's telling you we don't care what the y value is. If the x coordinate of that point is 3, it should be on the graph. Do you agree that every point on this vertical line has 3 as its x coordinate, right? It's the vertical line that goes through 3 on the x-axis. Anytime you see an equation, and y'all are allowed to have a half page of notes, so if anybody misses this, I'm not going to feel too sorry, because you literally could just write this down. Any equation that looks like x equal a number, the graph is going to be the vertical line that goes through this number on the x-axis. Everybody with me there? What if, instead of being asked to graph x = 3, what if we had been asked to graph y = 3? What would that graph look like? It's the horizontal line that goes through 3 on the y-axis, right? Notice every point on that horizontal line has 3 as its y coordinate. So again, you're going to see one or the other of these on the test. It could be either one. I would expect you to be able to deal with either of them. So anytime you see an equation that looks like y = 3, the graph is always going to be the horizontal line that goes through this number on the y-axis. Everybody with me? Okay. Problem 10. Problem 10 it gives us this equation 4x minus 2y equals 8, and it asks us to find the x-intercept and the y-intercept. There is a very simple way to do this, especially when the equation's given in this standard form, where we've got our x and y on one side and our constant term on the other. So what I'm going to do, let me come over here where I got a little workspace. So I've got my equation, 4x minus 2y equal 8. Remember, every point on the y-axis has 0 for its x-coordinate, right? So I'm going to do this little t-chart. And with my equation, 4x minus 2y equal 8, I'm going to plug 0 in for x, and I'm going to find the y value that goes with that. So y'all look at it. If I plug 0 in place of x, what am I going to get for y? We've talked about this as well. -4, right? Y'all look, do you agree that if I plug 0 in for x, 4 times 0 is 0? And 0 minus 2y is just minus 2y. So if I plug 0 in for x, this equation just becomes -2y equals 8. And we all ought to be able to look at that and see that y would have to be -4. -2 times -4 is 8. And if you don't see that, solve that equation by dividing each side by -2. And you literally get y is -4. So 0, -4 is one of the points on this graph. But we know that's a point on the y-axis. Then -4 must be the y-intercept. And then to find the x-intercept, every point on the x-axis has 0 for its y-coordinate, right? So all I need to do is plug 0 in for y and find the x value that goes with it. So if I plug 0 in place of y in this equation, what's x going to be equal to? 2. Because if I plug 0 in for y, -2 times 0 is 0. And 4x minus 0 is literally just 4x. Do y'all see that? So if I plug 0 in for y, my equation just becomes 4x equal 8. And I'm sure we can all see that 4 times 2 is 8. So x has to be 2. But again, if you couldn't, you just divide both sides by 4. And you literally get x equal 8 divided by 4, which is 2. So 2 is our x-intercept, because 2, 0 is a point on the graph, and any ordered pair that has 0 for its y-coordinate is a point that's on the x-axis. So there's one almost just like this on the test. And so make sure when you're asked for the x and y-intercept, make sure you clearly label for me which one is the y-intercept and which is the x-intercept, okay? Because sometimes students get those mixed up, and I want to make sure you understand the one that has 0 is its x-coordinate. Whatever that y value is, that's the y-intercept. And the one that has 0 for its y-coordinate, whatever that x-coordinate is, that's the x-intercept. Everybody with me? So pretty straightforward. Problems 11 and 12 are both asking us to find the slope of a line. So obviously you got to know the slope formula to do that. Slope is y2 minus y1 over x2 minus x1. And now you're allowed to have a half a sheet of notes. So the formula shouldn't be any problem for you to remember, since you don't have to remember it if you remember your half sheet of notes. So look, to find the slope, just look at these 2 points and say, okay, 4 is my x1, -3 is my y1, 2 is my x2, 9 is my y2. And so slope is y2 minus y1. Now be careful with your signs. That's going to be 9 minus -3, y2 minus y1, over x2 minus x1. That's 2 minus 4. 9 minus -3 is really 9 plus 3, which is 12, over 2 minus 4, that's -2, and 12 divided by -2 is -6. So that's the slope of the line that passes through those 2 points or contains those 2 points. Everybody with me? Simple. Problem 12 is asking you to do the same thing. Find the slope of the line. So we've got our x1 and y1 and our x2 and our y2. And so slope is y2 minus y1. That's negative 7 minus 6 over x2 minus x1. That's 2 minus 2. So notice negative 7 minus 6 is negative 13 over 2 minus 2 is 0. Do not leave that as your answer, because I don't know if you know what negative 13 over 0 is. What is negative 13 over 0? It's undefined. So remember, when you're doing division, if you had 0 on top and negative 13 on bottom, that'd be okay. But you can't divide by 0. If you've got 0 in the denominator, it's undefined. Then notice on that problem, on number 12, it doesn't just ask you to find the slope. It says find the slope and then determine whether this line is a horizontal line, a vertical line, or neither. So which is it? Is the line that these points pass through going to be horizontal, vertical, or neither? What if I said vertical? What if you couldn't remember the difference? So this one is going to be vertical. Every single line that has undefined slope is a vertical line. If it had been the other way around, if your points had been 6, 2 and negative 7, 2, in that case, you'd get y2 minus y1, which would be 2 minus 2 on top, over x2 minus x1, negative 7 minus 6. And so that would give you 0 over negative 13. Now that's not undefined. 0 divided by negative 13 is 0. Every single line that has a slope of 0 is a horizontal line. So when you do that problem, if you get undefined for the slope, then that line must be a vertical line. If you get 0 for the slope, that line must be a horizontal line. Of course, if you don't get either of those, if you get some number like this one, like negative 6 on the last problem, that would be neither. Like technically, I can tell you that this line it's not horizontal, it's not vertical, it's falling from left to right because it's a negative slope, right? Undefined vertical, 0 horizontal. Let's say that you find the slope and it's undefined, or maybe you find the slope and it's 0 and you can't remember which is horizontal and which is vertical. How could you still tell me whether this line is horizontal or vertical, even if you can't remember if undefined is horizontal or undefined is vertical? What could you do? Plot these 2 points on your scratch paper and draw the line through them, right? So I'm just saying, I always have students who get these backwards and the slope will be undefined and they'll say, oh, horizontal line. I hate to count off half the credit because of that, but the student just got them mixed up. But the bottom line is you could have just real quickly plotted those 2 points and just drawn the line to see if it's horizontal or vertical, right? Okay. Problem 13. Okay, so now we're going to get to some problems where we have to actually find the equation of the line, and I didn't write all that out, but it says to find the equation of the line that contains the point 2, 1 and has slope negative 3. This is where we're going to use that point slope formula. Y minus y1 equals m times, in parentheses, x minus x1. This problem, we're already ready to write that equation of the line in point slope form. 2 is our x1, 1 is our y1, m, our slope, is negative 3, right? So I'm just going to write it out. Y minus y1 is going to be y minus our y1, which is 1, equals m, which is negative 3, times, in parentheses, x minus x1, that's going to be x minus 2. That's the equation in point slope form. And notice on the practice test, that's not what I asked you for. I mean, you're going to need to do that to get to where I'm asking you to get to. I'm asking you for the equation in slope-intercept form, which just means now you need to distribute this -3 and then add 1 to each side. Remember, slope-intercept form is the one where y is by itself. So I need to distribute -3 times x is -3x. -3 times -2 is +6. And then I just need to add 1 to each side. And when I do, I get y by itself equals -3x plus 7. That's the equation of the line in slope-intercept form. Everybody see how to do this? So that one's really easy. If you got that point slope formula, you've been given exactly the information you need to just write it out in point slope form right away. You do that, and then you distribute whatever your slope is, and then you move this number that's over here with y, whatever that y1 was, you move it to the other side, and now that's the answer in slope-intercept form. Everybody good there? Problem 14 is really the same idea. The difference is, in problem 13, you were given a point that's on the line and you were given the slope. This time you want, in problem 14, you're not given the slope. You're actually given 2 points that are on the line. Well, you can't write the equation of the line without the slope, but this gives you a way to find the slope, right? You're going to need to use the slope formula first. So you first use the slope formula, find the slope. y2 minus y1 is going to be 1 minus 4 over x2 minus x1 is going to be -4 minus 2. So -4 minus 2. 1 minus 4 is -3 over -4 minus 2 is -6. First of all, negative over negative is positive, right? And 3/6, if you simplify it, reduces to +1/2. Everybody see that? In other words, 3 goes into 3 once, 3 goes into 6 2 times. And of course, negative over negative is positive. So now we know our slope is 1/2. So now we've got these 2 points they gave us, 2, 4 and -4, 1. Doesn't matter which of those I'm going to use. I'm just going to use 2, 4. We can make that our x1 and y1. And now we've got our slope, which is +1/2. Now I can use this same point slope formula idea that I used on the last problem. Y minus y1, well, our y1 is 4, right? So that's going to be y minus 4 equals m, which is 1/2, times x minus x1. Our x1 is 2. So x minus x1 is going to be x minus 2. And there is the equation in point slope form. And just like we did on problem 13, we now need to distribute the 1/2 and then add 4 to each side to get y by itself, at which point it'll be in slope-intercept form, and that's what we're asked for. So 1/2 times x is just 1/2 x. 1/2 times -2 is -1. So I'll get y minus 4, sorry. So 1/2 times x is 1/2 x. 1/2 times -2 is -1. Now I have y minus 4 equals 1/2 x minus 1. I just need to add 4 to each side to get y by itself. So I get y by itself equals 1/2 x plus 3. Because -1 plus 4 is +3. And so there is the equation of the line in slope-intercept form. Y equals 1/2 x plus 3. Is everybody good there? Again, the problems like this on the test are very similar to these problems.
What's the slope formula?
The slope-intercept formula?
Yeah.
So the thing to remember about slope-intercept form, first of all, you know when you're looking at an equation where you got y by itself on one side, you know you're looking at slope-intercept form, right? And when you know you're looking at slope-intercept form, you should know that the number that's multiplied times x is the slope and the constant term is the y-intercept. That's why it's called slope-intercept form. Everybody with me? Is that good? Okay. Problems 15 and 16 both come from 2.4. That's the thing where you got the parallel perpendicular line thing. So problem 15, there's two parts. I think there may only be one of these on the test just because I was a little concerned about the length if I made you do these twice. But here's what you're being asked to do. You're given the equations of two different lines. You're given an equation 4x plus 3y equals 12. Its equation is a line. You're also given an equation y equals 3/4 x minus 2. Its graph is a line. What you're being asked is, are those two lines that are the graphs of these two equations, are they parallel lines or are they perpendicular lines or are they neither? And to know that, you need to know the slopes of both lines. So notice in each of these parts of problem 15, I've given you the slope of one of the lines, at least you should see that I have. This second equation, what would be the slope of that line? Y'all, yeah, y'all are not inspiring confidence in me here. Y equals mx plus b. M is 3/4. Everybody see that? So if I were to graph this equation, y equal 3/4 x minus 2, the slope of that line would be 3/4. I need to figure out the slope of this line. The problem is this is not in slope-intercept form. I need to put it in slope-intercept form. In other words, I need to move things around until I have y by itself. So to do that, well, I got to get this x on the side opposite y, right? So I need to subtract 4x on each side. When I do, that's going to give me 3y equals negative 4x plus 12, right? Now I need to divide each side by 3. I'm trying to get y by itself to get it in slope-intercept form so I can just look at that equation and see its slope. So I got to divide by 3. And if you do that on one side, you got to do it on both sides. And that means you got to divide every single term on both sides by 3. So when I do that, I get y by itself equals negative 4/3 x. 12 over 3 is 4, so plus 4. Okay, so the slope of this y equal 3/4 x minus 2 line, the slope is 3/4. What is the slope of the line that this is the equation for? Not 4/3, negative 4/3. Okay, do y'all agree that these two lines are not parallel lines because parallel lines have the same slope? Are they perpendicular lines? Yes. Why? Because the slopes of perpendicular lines are negative reciprocals. Again, it's something we talked about kind of toward the end of class last week. Negative reciprocals means two things. One, it means they're negatives of each other. In other words, they have opposite signs. Two, it means they're also reciprocals. So negative reciprocals means the two numbers have opposite signs and one is the reciprocal of the other. Positive 3/4, negative 4/3. Those two numbers are negative reciprocals. Then the two lines that would be the graphs of these two equations must be perpendicular lines. So that's what you're being asked. Are the two lines that are the graphs of these two equations parallel lines or perpendicular lines, or neither? If they had had the same slope, they'd be parallel lines. If they didn't have the same slope and the slopes were not negative reciprocals, they would be neither. They're just two lines. They're not parallel or perpendicular. Okay, similar problem on the B part. Again, I think you only get one pair of these on the test, but this should kind of get you ready for whichever it is. Okay, do y'all agree that if I look at the second equation, the graph of that equation, that line has a slope of positive 1/2? Do y'all agree? We got to figure out the slope of this line, just like we did up here. We got to shuffle things around until we have y by itself. So the first thing I'm going to do is subtract 2x on each side, trying to get y by itself. So I get negative 4y equals negative 2x plus 5. And I got to now divide everything by negative 4, because remember, slope-intercept form, we need y by itself. So when I do that, I get y by itself equals negative 2 over negative 4 is positive 2 over positive 4. Negative over negative is positive, and 2/4 is 1/2. We want to simplify it. So I get y equals 1/2 x minus 5/4, right? Positive 5 over negative 4, that's negative, so minus 5/4. Do y'all agree then that the slope of this line is 1/2? Because it's y equal m times x plus b, so 1/2. Do y'all agree then that these two equations, if you looked at their two graphs, those two graphs would be parallel lines, lines that are parallel to each other? Because if two linear equations have the same slope, then their graphs are parallel lines, right? Parallel lines have the same slope. So everybody see how to do that? And that's all you're being asked. Are the lines parallel, or are they perpendicular? Or are they neither, right? If neither one of those things happen. Okay, problem 16, also, and like I say, I think there's only one pair of these on the test, just, for time's sake. Problem 16, you're asked again to find the equation of a line that contains the point or passes through the point negative 3, 2, and is parallel to the line whose equation is y equals 2/3 x minus 7. Do you see that what they're really asking you to do is find the equation of the line that contains the point negative 3, 2, and whose slope is 2/3? Because see, it didn't specifically tell you the slope of your line, but it did tell you that your line is parallel to the line with this equation. And so again, parallel lines have the same slope. The slope of this line is 2/3. Then the slope of the line we're looking for must also be 2/3. Everybody see that? So look, we've got our x1 and our y1, and we've got our m, our slope. So again, we're going to that point slope formula. Y minus y1 equals m times x plus, m times, in parentheses, x minus x1. And we're just going to plug our stuff in. Our value of y1 is 2, so that's going to be y minus 2 equals m. Well, our value of m, our slope is 2/3, times x minus x1. Now be careful, y'all. Look, our x1 itself is negative 3. So y'all see that x minus x1 is going to be x minus negative 3, which is really x plus 3. Y'all see that? And so there's the equation in point slope form. We're asked to put it into slope intercept form. I need to distribute. 2/3 times x is 2/3 x. 2/3 times positive 3 is positive 2. So I've got y minus 2 equals 2/3 x plus 2. And of course, I now need to add 2 on each side. And when I do, I get y by itself on one side equals 2/3 x. And then 2 plus 2 is positive 4. So y equals 2/3 x plus 4. And there it is in slope intercept form. Everybody see that? Simple to do. You just have to know parallel lines have the same slope. So since our line is parallel to the line with the equation y equals 2/3 x minus 7, then our line must have a slope of 2/3, right? Okay. Problem 18. Now we're getting into stuff that we did tonight. In problem 18, we were asked to find the domain of this rational function. Somebody tell me, what is the one number in the universe that is not in the domain of this function? Positive 5. Do y'all see that if I replace x with 5 here, I'm going to get 5 minus 5 equals 0 in the denominator, then x can't be 5. Again, I think everybody ought to be able to look at this and see that if I replace x with 5, I'm going to get 5 minus 5 is 0. But if you can't see that, all you have to do is say, okay, I need to know what value of x makes that denominator x minus 5 equals 0. And of course, you add 5 to each side, and you got x equal 5. Then the thing to remember is, this is not your domain. In fact, 5 is the one number in the universe that's not in the domain. So, again, my advice is do the number line graph. If this is the number 5, this number line graph goes forever to the left toward negative infinity, to the right toward infinity. If you were to shade the entire number line from negative infinity to infinity, that would represent the set of all real numbers. That is our domain, except we need rounded parents on either side of 5 to say we got to stop just before we get to 5. But then as soon as we get past 5, everything after that's in the domain. And so we get two intervals here. The interval from negative infinity to 5, unioned with the interval from 5 to infinity. Anything in this interval or this one is in the domain. Everybody see how to do that? That's super easy, right? Just whatever number makes the denominator 0, that's not in your domain. And so the domain is the set of all the real numbers except for that. And again, the one on the test, very similar. Everybody good there? Problem 19, also asking us to find the domain, but this time we're being asked to find the domain of one of these square root functions. So remember, here the trick is you can't replace x with any number that's going to cause you to get a negative number under this square root. You can only replace x with values that make this expression x minus 4 either greater than or equal to 0. Everybody with me? So whatever that is, you're just going to say whatever's under the square root has to be greater than or equal to 0. Solving this is easy. Add 4 to each side and you're done pretty much with that, right? You get x is greater than or equal to 0 plus 4 is 4. That is your domain. You just have to write it in interval notation, right? So in interval notation, that's the interval from 4 to infinity. You're going to need the square bracket around the 4 because of the or equal to part. And if you have trouble looking at a statement like x is greater than or equal to 4 and sort of visualizing what that's going to look like in interval notation, again, if you needed to, you could just take a second and draw the number line graph. Wherever 4 is on the number line, all the values greater than 4 would be all of this stuff to the right of 4 on the number line, going toward infinity. And because of the or equal to part, we know we need the square bracket around the 4, right? So again, if you need to write it in, sketch the number line graph to help you write the interval notation, there's nothing in the world wrong with doing that. But make sure you give me the answer in interval notation. Everybody see how that goes? Again, the one on the test, very similar to this one. And now we're down to all those combinations of functions. And notice these two functions, you're using this on all of these problems, right? So number 20, f minus g of x. Well, remember that is f of x minus g of x. So we're going to write our function f of x, which is x squared plus 1, minus our function g of x, which is 2x minus 1. So now when we do this, remember this minus sign here is going to reverse the signs in the parentheses, in this second set of parentheses. So it might be worthwhile for you to just take a second and write this out without the parentheses, where you've got x squared plus 1, but then you've got minus 2x. And notice here's the one where students miss it. They get the sign wrong. See where I'm pointing? Right there. Minus a negative 1 is really plus 1. Everybody see that? Everybody good there? Do you see that this would be the negative of 2x, which is negative 2x, but it would also be the negative of negative 1, which is positive 1. Y'all see that? A minus sign outside parentheses reverses the sign of every term in the parentheses, right? Now all you're doing is combining like terms. So you got x squared, nothing to combine it with, minus 2x, there's no other x term to combine it with. But you can say with the constant terms, 1 plus 1 is positive 2. So you get x squared minus 2x plus 2. Everybody see how that goes? We good there? Problem 21 asks us to find f times g of x. That's literally just f of x, which is x squared plus 1, times g of x, which is 2x minus 1. And we just multiply, we distribute or FOIL, however you view it here. And so x squared times 2x is 2x to the third. X squared times negative 1 is just negative 1x squared, or just negative x squared. So if you wrote negative 1x minus 1x squared, I wouldn't count off, but you don't really need the 1 there. 1 times 2x is positive 2x. And finally, positive 1 times negative 1 is negative 1. And again, remember, if I had any like terms here, I would need to combine them to simplify it. But in this problem, I don't. It's kind of already simplified once I multiply it. And there's f times g of x. Everybody good there? F composed with g of x. Remember, my advice is when you start finding f composed with g of x. Yep, sorry. So then we're asked to find f composed with g of x. And my advice is before you start writing all the functions out and doing stuff, just write f of g of x to help you remember what it's telling you to do. So, in fact, let me see if I can zoom out a little bit. Maybe that's a better way to go. Let me see if I can focus. So that helps us because it tells us, okay, we write our function f of x out, but then wherever the x is in that function, we got to replace it with the entire function g of x. So f of g of x. Well, f of x is this function x squared plus 1. But this is f of g of x. So where the x is up here, I've got to replace that x, where the parentheses are, where I've written it down here. I got to replace that x with this entire function g of x, which is 2x minus 1. And so when we do that, well, I'm going to do some scratch work because I've got to do 2x minus 1 in parentheses squared, right? And by the way, once I do that, whatever I get, I'm just going to add 1 and be done. Do y'all see? So I've got 2x minus 1 times 2x minus 1. That's 2x minus 1 in parentheses squared. And 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is another negative 2x. And negative 1 times negative 1 is positive 1. And notice negative 2x minus 2x is negative 4x. So I get 4x squared minus 4x plus 1. So 4x squared minus 4x plus 1. Now, y'all look and be alert. Is this f composed with g of x? It's not. What do I still need to do? Yeah, be careful. So look, this is what this is, right? Don't forget, we still have this plus 1 out there. Y'all see that? So just trying to help you remember that there's little minor things. If you're not careful, you'll kind of like not see that or kind of forget about that being there. So in the end, I'm going to get 4x squared minus 4x plus 2. Everybody see that? And that's our function f composed with g of x. Okay, now, finally, this last problem asks us to find f composed with g of 2. How should I do that? I need to look up here at what I got in problem 22. Do y'all agree? So problem 22, 4x squared minus 4x plus 2, that is what I found for f composed with g of x. Well, if this is f composed with g of x, do you agree that f composed with g of 2 must be whatever I get if I plug 2 into this thing in place of x? Do y'all see that? So I'm going to have 4 times 2 squared minus 4 times 2 plus 2. All I did is in the function that I just found in problem 22, f composed with g of x, all I did is I plugged 2 into that function to find f composed with g of 2. And of course, I got to evaluate it. So 2 squared is 4. So I've got 4 times 4, which is 16. Then minus 4 times 2 is minus 8. Don't forget we got plus 2 out here at the end. 16 minus 8 is 8, and 8 plus 2 is 10. So f composed with g of 2 is 10. Everybody see how to do that? Okay, what is the danger point for you on problem 23? Well, what if you missed problem 22? Do y'all see that's going to be an issue for you, right? If you miss problem 22, and then you just, in problem 23, plug the number 2 into the wrong answer from 22, you're going to get the wrong answer on 23, right? That's what computer programmers call garbage in, garbage out. But here's the thing. I try to never put a student in double jeopardy. I'm much like our legal system. If you miss problem 22, you're going to lose some points. You know, you might get partial credit, but you're going to lose some points for problem 22 if you miss it. If you miss problem 23, but the answer you got on problem 23 would have been correct if your answer on problem 22 had been correct, then I won't take off points for 23. Y'all see that? I will say this in closing, because this is the last thing that's on here, because the next problem that's on there is asking about inverse functions, and that's section 2.7. We didn't get to it. And by the way, remember I had told y'all 25 and 26, we'll never cover that. We're not going to cover it. We don't need to. It's not in the course. It's not on the final. And we are beyond the point of having time to cover things that we don't need at this point. But that very last problem is from 2.8. So problem 24 and 28, we will have to cover those because you're going to see them on the final exam, but we'll cover what you need for those. What I wanted to tell you about this composing functions thing is, you know how we say that f composed with g of x is literally f of g of x? So when I ask for f composed with g of 2, so look, this is what I want y'all to see is sort of our last thing tonight. So f composed with g of x, we've talked about the fact that that is f of g of x. Then do you agree that another thing we could say is, let me do this so I don't get marker on the table. We could also say this, f composed with g of 2 is also, it must be equal to f of g of 2. Now y'all don't worry about this because I've already told you on the test, you can find your f composed with g of x, and then whatever value you're asked for here, you can just plug that into your answer from 22. If 22 is wrong, I'm going to mark that one wrong, but if 23 is correct based on your answer for 22, I wouldn't take any points off there. But this also kind of helps you find a way to check your work on 22. So let me show you this real quick. If f composed with g of x is equal to f of g of x, then f composed with g of 2 must also be equal to f of g of 2. And for that, if you find g of 2, which simply means plug 2 into this original function g of x, which was 2 times 2 minus 1, that's 4 minus 1, which is 3. Does everybody agree that g of 2 is equal to 3? In other words, if I plug 2 in here, I find that g of 2 is 3. Well, then f of g of 2 must be f of, well, what is g of 2? It's 3, right? Then f of g of 2 must be f of 3. In other words, if I plug 2 into the function g and plug that number into the function f, that would give me 3 squared plus 1, which is 10. Isn't that the same thing we got here for f composed with g of 2? See, that's what composition of functions is really doing. But again, I'm not testing you over that. I'm fine. If you get an answer in 22, whatever that answer is, plug this in that next problem, plug this number into that function. If you get the correct answer based on whatever your answer here was, I'll count that one right. Everybody with me? But I did want y'all to at least see that's what's going on. You could kind of see that this does kind of give you a way to check it if you know that, because if you find it this way, where you do f composed with g of 2 by first plugging 2 into the function g of x, and then plug in whatever that answer is into the function f of x, you know you ought to get the same answer as you get if you plug 2 into this, what you found in 22. You should get the same answer. If you don't, it probably means you did something wrong there. But anyway, you don't have to worry about that. I'm just saying that's a thing. Okay, I'm going to turn off record just so this thing doesn't get like overlong while we're not doing problem.